Good morning, all of you. Today we have to perform the bending test. So naturally we have to consider in our previous lecture the working of universal testing machine. And this is our movable crosshead, this is our bottom crosshead. And this is our the wooden beam we have to set here. This is our the two different support. Okay. And first of all we have to measure the length of that beam, the dimension of that beam. The dimension of that beam is it is 750 mm, but the center to center distance of this support that is only 40 mm, and the distance which is given here we have to require the additional beam here because it cannot be slipped during the performance of test. Again the criteria for that, the loading criteria, we have to apply that load, that is our simply supported beam, point load acting at center. Then we can directly calculate our bending stress value according to our bending formula, that is m by I, sigma by y, I by y, isn't it? And according to that we have to check the our bending stress value, whether that beam which is cut at bottom side or top side. So normally we know that above that neutral axis all the fibers are compressive in nature, and below that neutral axis all their fibers are tension. So we have to check here whether our beam which is crack at bottom side or top side. Remaining procedure for that, the again we have to perform the practical by using universal testing machine. So we have again the computerized machine is there. We have already studied about that. Then we have to input parameter is there. We have to put input parameter in that test by using the same software. Now again, first of all, we have to control this panel by using that machine. So we have to require whether whatever reading which is showing here, same reading which is showing on our control panel. So first of all, I tear that load, then displacement is also 0. Isn't it? Now the test type, input parameters, bending test is there, graph is load versus displacement. Okay, so which type of bar is there? Flat. So you have to put our parameters. So again here serial number, serial number. So today's date is same 18.8 2020. Batch is capital A1, A1. Then span length is we have to required only support to support distance, that is 400 mm. The width of that specimen is 50 mm. Thickness is also 50 mm. Now here the bending type, there are two different method which is given to you, 3-point and 4-point. How it can be considered as a 3-point and 4-point? It is considered as two different support and 1-point load. So that's why that loading which is called as 3-point load. If the two supports are there and then 4-point means the equal distance we have to require. So there are, for that particular test we have to require the different assembly. So as per our the given case, our case is 3-point. Okay. So that parameter is same. Deflection we didn't put any parameter here. So that is the input parameter is okay. Now before going to start, we have to require some XY parameters because we have to plot here graph load versus displacement. Minimum is 0, maximum is 50 and 0. So naturally this is our wooden material. It doesn't take 100 kilonewton. So I change it 50 kilonewton. Okay. So again that whatever output parameters are required, the bending strength, displacement, maximum displacement, percentage of elongation we didn't know, flexural modulus and final area which is required here. So I put here the output parameters, so it is okay. Now before again we have to check whether all the parameters, input parameters and output parameters is correct or not. But again to start this test, again I tear that load because some load which is showing here. Clear? So you have to start it and then I start the test. हाँ कर दो. just repeat because the setup is not ready. So again I put test type same. Okay. Flat bar is okay. All the parameters that is okay. Okay. So this is no because again I tear that load 0. XY parameters. Okay. Percentage elongation final area. Okay. And I start. वो बंद है ना बॉल. Again the same criteria, the loading criteria is same. Then we have to apply that load which is increased by 0.4 kilonewton. Same setup is there, same machine we have to use, only test is different. That is bending test. This why it is not considering the loading criteria because it is not such that loading cell exactly on that beam. Light array. थोड़ा सा बस. You see here, the load is increases, displacement is also increases. See here, the load is increased and suddenly it is break into two pieces. बस हो गया बस रुक दो Now again we have to copy this graph and put in our folder. Save it. Write the name is bending test. So you have to copy it, take a printout and attach in our. Now see, this is our the failure pattern of beam. See this is the crack, okay, which is developed exactly at bottom side, below that neutral axis. So beam is always failure on tension side. So that's why we have to design our beam for tension. And the tension that is below neutral axis. So in design of beam, so we have to provide our reinforcements below that neutral axis, isn't it? Okay, so we will stop here.